Hi students, welcome back to my channel Math Solutions by AK. Today we are going to discuss about topic from 6th class, that is whole numbers is our topic. So whole numbers is not only the topic for 6th class, it comes under the basic concept for all other classes also. So better all the students can watch this video. Okay. So now when you talk about numbers, we start with natural numbers. Natural numbers. So what are natural numbers are? So when you are asked to count something, okay, we'll be starting with the 1, 2, 3, and so on. So these numbers which you start counting 1, 2, 3, so they are called natural numbers. So that is 1, 2, 3, 4, 5, and so on. They are countless, so infinity. So natural numbers, they are indicated by capital N. So the natural number set is represented like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. That is infinity. Okay. So 1 is a least natural number. Least natural number and ends to infinity. Ends to infinity. So now when you are adding 1 to any natural number, so what you get? So obviously your answer will be the next number. So example, if you are taking the number 9, for that I am adding 1. So what you get is 10. So obviously for 9 the next number is 10. Okay. And the same way, if you are taking the example 15, adding 1, you will be getting 16. So for 15 the next number is 16. So here we call this 10 and 16, they are successors. So that is 10 is a successor of 9, and the same way 16 is the successor of 15. So successor means, don't get confused sir, it is quite old. That is, successor means the next number. Successor is nothing but next number. Okay. So when you're adding 1 to any natural number, you get the next number, and that next number is nothing but, we call it as a successor. Now if suppose if we are subtracting, what is the concept? Subtracting 1 from any natural number, what you get? So for example, the same, if you are taking 9, from that 1 you are subtracting, you will be getting 8. So obviously 8 is a previous number of 9. So actually, other example, if you are taking 16 minus 1, 15, again 15 is a previous number of 16. Okay. So in primary classes you might have learned it as a before number. So here 8 is called the previous number, predecessor of 9, and 15 is also the, okay, also means here we can call it as, is called the predecessor of 16. So the previous number of 9 means it is 8, the previous number of 16 means it is 15. So previous number will be calling it as predecessor. So now what happens if we are subtracting like this only from all the natural numbers? Can you subtract? So from 9 you are subtracting, you are getting 8. From 7 you are subtracting 1, you are getting 6. From 5 you are subtracting, you are getting 4. From 4 if you are subtracting, you will be getting 3. From 3 if you are subtracting 2. From 2 if you are subtracting 1. From 1 if you are subtracting, so it will be what? So what is your concept is, here we are talking about natural numbers. So from natural number 1, if you are subtracting 1, what is your answer? So generally, as you are aware of 1 minus 1, you will be telling 0. But in the concept of natural numbers for 1, there is no predecessor of 1. Why? Because 1 is the least natural number, already we discussed. Okay, 1 is a least natural number. So 1 itself is starting. So less than 1, there is no other number. So there doesn't exist any predecessor for 1. Okay, now the concept now is whole numbers. So for the set of natural numbers, that is 1, 2, 3, 4, 5, 6, and so on infinity. For this set, if you are including 0, then we call this set of numbers as whole number set. That is, whole numbers are indicated by capital W. That is, whole number set is represented like this: 0, 1, 2, 3, 4, 5, and so on, so infinity. Okay, so in whole numbers, 0 is the least whole number. 0 is the least whole number. Least whole number. So highest will be infinity. Even in the natural numbers also, the highest is infinity, and in the natural numbers, the least is 1. In whole numbers, the least is 0. Okay, so now we'll deal with how to represent whole numbers on number line. Whole numbers representation on a number line. Whole number representation on a number line. So let us draw a line. So from 0 it starts: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For the time being, I am taking only up to 10. So this is a representation, means from 0 you will be starting the representation, and the maximum how much you want you can extend up to, okay, whatever the number line you require. So now addition of whole numbers on a number line. How to add this one? For example, if you are taking a number 3 and 4, how to add this one? So from 0 you start, divide the number line into equal units: 5, 6, 7, 8, 9, and 10. So likewise, you represent a number line. From here, what is your requirement? So your requirement is 3 added to 4. What is your answer? So 3. 0 to 3 you approach. This is your first number. Okay. From there, you are traveling 0 to 3. 1, 2, 3. 3 units plus further still it is there. So forward counting should be done. Forward counting for addition. Forward counting will be done for the additions. Now plus 4 units. 1, 2, 3, 4. So now you approached the answer, that is 7. So from 0 to 3, so for the 3 is a number, you are adding 4 more values, you are getting 7 is the value. So therefore you conclude 3 plus 4 gives you 7. Okay, so this is how you will add whole numbers on a number line, how you represent the addition of whole numbers. Now the same thing we'll see for subtraction of whole numbers on a number line. For subtracting, what to do? So in addition you have done forward counting. So in subtraction what you do is backward counting. Subtraction, it means backward counting. For example, if you are taking 9 minus 6, 9 minus 6 gives you what is your question. So this we need to represent on a number line. So what to do is, again the same thing you do, draw a number line, represent whole numbers on that. So this should be done neatly by taking each single unit equally. So now I represented up to 10. So obviously I know the answers. 9 minus 6 gives you 3 only. So I presented up to 10 itself. So now, yeah, number is 9 here. Your given number, this, okay, this highest number is 9. So it should take from that. So I said you already it is a backward counting. So from here what you do is count from here, means you go to 9, you're taking 9 values here. Okay, from here 9 backward counting you do. 6 is to be subtracted. 1, 2, 3, 4, 5, 6. So how many values you deducted? 1, 2, 3, 4, 5, 6. So now you approach the answer, that is 6. 9 minus 6 is 3. So therefore 9 minus 6 is 3. So 9 minus 6 gives you 3. So this is the way how you represent subtraction of whole numbers on a number line. Okay. Now representation of multiplication will do. So how to represent multiplication of whole numbers on a number line? Multiplication of whole numbers. So again the same thing, if suppose you are asked to find out 4 into 3, okay, is what? So to represent this on a number line, what you do is draw a number line as usual. For these multiplications you need to draw a lengthy number line. Okay, and mark the same 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14 and 15. So I stopped up to 15 now. So now 4 is taken 3 times is your concept. 4, the number or 4 values taken thrice is your concept. So what you get is, so 0 to 4 you got 1, 2, 3, 4. So 4 units. This is giving you 4. From here, how many times you should take? 3 times. This is 1 time. Okay, again 1, 2, 3, 4. So up to here it is 1 more, that is 4 more. Okay, 1 more time is up to 8. So you want 3 times. So 1, 2, 3, 4. This is again one more 4 count. So this is a thrice. So 1, 2, 3. So 4 counts you are taking thrice. 1, 2, 3. So what is your answer? You approach the value 12. So therefore we conclude 4 into 3 gives you 12. This is how you represent multiplication of whole numbers on number line. Okay. Hope you understood the introduction of whole numbers. So in the next class, we'll be dealing with the properties of whole numbers. For more videos, you please subscribe to the channel and like, share, okay, and comment if you want. Already I said you in the previous class also. So if you want any other problems of any class also, any chapter also, you can comment. Please suggest me in the comment section so that I can solve in the further classes. Okay. Thank you. Thank you for watching my videos.